Hello guys, welcome back to my channel. Based on African motives, still looking into mathematics N2. So actually in this platform we have got the question paper which was actually written in June 2022 for mathematics N2, which is the X paper. So these are actually the August exams, but we know that we started in June. So we just want to see how and what we're supposed to do here, because it was actually 3-hour paper. It's a 3-hour paper, as we know, and also we know the instructions and the information mostly that you're supposed to have. So we shall just quickly rush through the question paper so that we do not waste much of your time, because we want to see how we are supposed to answer the given questions. There we are given that to simplify on question 1.1, which is on question 1.11, which is e to the exponent of ln. So that one is just 1 mark. So what do we have there? E to the exponent of ln e to the exponent of x, like that. How can we simplify that part? All right, we know that whenever we are given e, let's have e to the exponent of ln x, like this. If it is a certain term like that, it is going to give us x. That is what we know. So that means if it is e to the exponent of ln and we have got e to the exponent of x here, this is going to give us e to the exponent of x. All right, so that is a answer there. As you can see, it's just 1 mark, guys. Okay, then the other part is now a logarithm that we are given to evaluate or to simplify that log without using a calculator, guys, without using a calculator. This is actually 1.12, not 1.11, but 1.12. All right, so that's the logarithm, guys. What can we do? How can we simplify such a logarithm? All right, here it's a matter of writing. Remember, guys, I told you about this concept of writing in terms of writing a logarithm in terms of a base and a number which are the same, like that. So this is going to give us a 1, as we know. So writing our logarithm in terms of a number and a number which are the same here, the base and the number being the same, we know that we are going to obtain a 1. So we have to write these numbers that we have here in terms of the bases, in terms of base 5 here, in terms of base 3, in terms of base 5. All right, so what are we going to do? Okay, this is minus 2, 1 over 5 here in terms of 5. We know this is a fraction, so it's 5 to the exponent of minus 1 from our laws of exponents, which is in base what? 5. So as you can see, we've got 5 and 5. This is what we need. All right, we have got 9 here that we need to write in terms of what? In terms of 3. So in terms of 3, 9 is 3 to the exponent of 2. This is the one which gives us what? 9. So that means we are going to have it as 7 log 3 to the exponent of what? Of 2 in base of 3. So as you can see, we've got 3 and 3. So we want to achieve this condition. That is what we want. All right, so let's move on. We have got 125 here that we are supposed to write in terms of what? In terms of 5. So we know that 125 is 5 to the exponent of what? Of 3. 5 multiplies itself 3 times, it's going to give us 125. But if you can see, there is already an exponent here which is there, which is minus 3. So that means we are going to multiply, because it's now an exponent and an exponent, which is going to give us 5 to the exponent of negative 9. Take note, there was already an exponent of negative 3, so it's going to be 5 to the exponent of 3 to the exponent of minus 3, like this. which is going to give us 5 to the exponent of negative 9. So that means we have got minus log 5 to the exponent of negative 9, which is in base 5. So us, what we need is to have this 5 and this 5. All right. If we are to cross-check properly here, yes, we have the number and the base, but there are these exponents that we are having. How can we get rid of them? These exponents here are minus 9, the 2, and the minus 1. How can we get rid of those exponents? Okay, we have our law. Remember, p log m, which gives us log m to the exponent of p, which means log m to the exponent of p is equal to p log m. So that's the law that we're going to use. You just need to multiply by the exponent. So that's negative 1 and negative 2, which is positive 2 log 5 base 5. All right, you do the same here. 2 times 7, which is 14 log 3 base 3. All right, you do the same here. Minus 9 and minus 1. So this one is same like this minus 1 there. So it's minus 9 times minus 1, which is a positive 9 log 5 base 5. So as you can see, guys, this is what you need. Once you can see log 5 and base 5, you know that one is a 1 because we said it from this law. Log a base a is equal to 1. So which means whenever this number and the base are the same, this whole part is a 1. So it means you've got 2 times 1 plus 14 times 1. This whole part is a 1. This whole part is a 1. 9 times 1 like this. So that's gonna be 2 plus 14 plus 9, which is actually going to give us 25. So as we can see, we no longer have the log from this part here because this whole thing is 1. This whole thing here is 1. This whole log here is a 1. So that's what you're going to have at the end. So guys, these are the steps actually that you need in order to simplify properly whenever you are working with a logarithm. All right, then another part on 1.2 is to solve for a. So all these we are solving for a, and it's 4 marks, 3 marks, and 4 marks, 4 marks, 3 marks, which is to make 16 marks for that on 1.2. So let's see, guys, how we were supposed to solve those. Okay, the first part there, let me see where I wrote this, or maybe I didn't even write this part. All right, so this is what we have there. That is the question on 1.21, and it's actually 4 marks there. So how can we solve for a, because the question is for us to solve for a there. All right, so what is best here, guys, is that we can write these numbers in terms of their simplest form. This 32, 1 over 2, 16 in their simplest form. At least we can be able to apply the laws of exponents provided that these bases are the same. So which is the simplest base that we can use between this 32, this 1 over 2, and this 16? Definitely it's base 2. So that means this 32, we know that is 2 to the exponent of 5. That is 32 for you. But already there is an exponent which is there, which is 2a plus 1. So what am I going to do with this exponent? Okay, this is an exponent and another exponent. So I'm just going to open a bracket for that exponent like this. Okay, multiply to 1 over 2. of which we know that 1 over 2, which is a fraction, is same as 2 to the exponent of a negative, just like what we did in the previous question. If you saw that on 1 over 5, we say it's 5 to the exponent of what? Of negative 1. But we have got a minus 6, which is the exponent, which was already there. All right, we move on to 16 in the same base of 2, which is 2 to the exponent of 4. But already there is an exponent of minus 4, which is already there. So you have to involve that exponent, guys. All right, then now, as you can see, we can expand brackets. Depends with what you want. You can apply any law here. Okay, here we can expand brackets. Then we are multiplying the bases, which are the same. So you are going to add the exponents. Remember that you are going to add the exponents because you are multiplying the bases, which are the same. So it's going to be 2 to the exponent of 5 into 2a plus 1, like this. Okay, plus this part, but as you can see, it's a plus and here there's a minus. So plus and minus, guys, is going to give us a minus. Take note, we applied this plus, but when it meets with this minus, which is already there here, it is going to give us a negative. All right, which is into a minus 6, like this. Everything is going to be 2 to the exponent of 4 times minus 4, which is minus 16. So as we can see that at this stage, this is now a single base of 2, and here we have got a single base of 2. So what do we know? We know that when these bases are the same, we are going to equate the exponents. All right, so which means we are going to have it as 5 into 2a plus 1, like this, minus 1 into a minus 6, like this, which is equal to minus 16. We are going to equate the exponents because the bases are the same. We know that. All right, then we are now left with a normal equation. As you can see, this is now a normal equation that you are used to, which is actually a linear equation. So you have to solve the linear equation, expand brackets, collect like terms, and so forth. So 5 times 2, that's 10a. 5 times 1, which is 5. So it's 5 times 2, 10. 5 times 1, which is 5. Minus 1, remember this minus 1, we obtained it from plus or minus, plus and minus here. So it's going to be minus 1 times a, which is minus a, minus 1 times minus 6, which is plus 6, is equal to minus 16. Take note, there is already a negative there. Then we can simplify further. Collect like terms. This is like 10a minus 1a here. So it's 10 minus 1. 10 minus 1, which is 9a. Okay, it's plus 5 plus 6. So it's 5 plus 6, which is 11, which is going to give us negative 16. Then at this stage, we can transpose 11 to the right hand side, which is going to give us minus 11 because it's a positive here, so it's going to change into a negative. So we've got minus 16 minus 11, which is going to give us minus 27. So 9a is going to give us minus 27 there. So actually you have to divide by what? By 9 both sides, so that we can find the value of a. So if we divide by 9, this is going to give us minus 3. So the value of a there is negative 3. So that's what we have, guys. And simply we have to apply the laws, as we can see. All right, then another question is also want to simplify, want to solve for a, but this time it's a log. All right, and I wrote it here. Okay, this time I wrote it here direct. So this is our log that we are given there, and most of us were surprised what is happening here. Okay, it's actually nothing, guys. As we can see, we've got log a minus 1, and everything now is raised to the exponent of 2, which is equal to log 10. Actually, there is nothing that we can do at the moment because we can't apply the square root here for the meantime to remove this exponent. We know that we have to introduce the square root. But first, let's work with this log 10 because we are used to this log 10. Remember, guys, we know that logarithm of 1 is 0, logarithm of 10 is 1, logarithm of 100 is 2, and so forth. So log 10 as a numerical value is equal to 1 because we are in base 10. Remember I told you guys that when the base is not given, it means you are in base 10. So it means this one is same as base 10 here, base 10 here. That is what it means. If the base is not given, you are in base 10. All right. So now I'm going to write this as log a minus 1 in base 10. Okay, everything to the exponent of 2, which is equal to, in place of log 10 base 10, I'm going to substitute with 1. So as you can see, that's what we have there. We have now written this in terms of a numerical value, where now we can remove this exponent of 2. How do we remove the exponent of 2? Remember, we have to introduce the square root both sides. So we are going to introduce the square root both sides to remove the square root. But we know that square root of any number is a plus or minus. So that means the moment you introduce this square root, you are automatically removing this exponent of 2. So you are going to remain with log a minus 1 in base 10, which is equal to plus or minus 1. So that means there are now two possible solutions there. There are now two possible solutions. All right, let's work out the solutions. The first solution can be from log a minus 1 in base 10, which is equal to plus 1. Or another one is going to be from log a minus 1 in base 10, which is equal to minus 1 because it's plus or minus. So now, as we can see, we are left with a normal logarithm that we are used to. We are no longer having these complicated situations that we had. So how now are we going to solve? Remember, guys, that we have a great relationship between log form and exponential form, where I told you guys that log a in base b is equal to c is same as a is equal to b to the exponent of c. This is exponent form, this is log form. So that means we have got this a minus 1 in terms of a. So a minus 1 is equal to 10 to the exponent of what? Of 1. All right, which is of which 10 to the exponent of 1 is same as 10. Okay, we have the same thing here. A minus 1 is equal to 10 to the exponent of what? Of negative 1 on that side. All right, so this is going to give us, if we transpose this to this side, because this is 10 to the exponent of 1 is 10. So if we transpose this minus 1, it's going to be plus 1. So we've got 10 plus 1, which is 11. So which means our a there can be 11. Okay, or we have to solve again here. A minus 1 is equivalent, remember, 1 over 10, guys, is 10 to the exponent of minus 1 is 1 over 10. I'm already saying the answer. So this is 1 over 10 here. Then we transpose minus 1 to this side is going to be a plus 1. All right, this is going to be a plus 1. And if we add 1 over 10 plus 1, we are going to obtain 1 and 1 over 10. So this is going to be 1 and 1 over 10. I don't know if you write it as improper fraction, this is going to be something like 21 over, is it 21 or 11 over 10, something like that. All right, but that is what we have there. So a is going to be 11 over 10 or 1 and 1 over 10 like this. or this is what we have, a which is 11. So actually that's what we had from this condition where we are given a logarithm where we need to first evaluate into a number so that we can remove the square by introducing the square root both sides. Then after that you now have a normal logarithm that you are used to, so you can actually solve. So that is how we are supposed to obtain these 4 marks. And on 1.23 again is to solve again, guys. This was all about A. Everything was all about A there on this question. So this is A is equal to log 8 in base 64. So how can we actually solve out this one? All right, this is it, guys. Maybe some of us it's easier to write it this way. Log 8 base 64 is equal to A. Maybe that's where some of you can easily see that we can actually convert this to exponential form. Remember I told you that this 8 is going to be equal to the base to the exponent of A. So it's 64 to the exponent of A. So what have I done? Converting from log form to exponential form, which is going to be easier for us to solve for A, because as long we are now in exponential form, what we need is to make sure that these bases are the same. So 8 to the exponent of 1 is equal to 64. It's 8 to the exponent of 2. But there is an exponent of A, so it's going to be 2A. Or maybe you can write it in base 2, in base 4, in base 2, yeah, in base 2 is fine, because this is going to be, in base 2 is going to be 2 to the exponent of 3 is equal to 64. In base 2 is going to be 2 to the exponent of 6, which is 6A. So still you are going to obtain the same answer. As long these bases are the same, you can equate the exponents. As long these bases are the same, you can equate the exponents. So 1 is equal to 2A. So therefore, divide by 2 both sides to find the value of A. So therefore, A is equal to 1 over 2. So that's what we had actually there. That's what we had from this question. So as we can see, guys, these questions, they just need you to apply the knowledge of what you have and so forth. Simplify the following algebraic fractions on question 2, which is 2.11 there. We are asked to simplify. That is what we had. So I shall just quickly brush through this question, guys. As you can see, we've got about 10 marks from that question, which is 6 marks from this one and 4 marks on another one. Okay, so definitely we know that actually we need to factorize here. So we are going to factorize these expressions aside. 2a squared minus 3ab plus b squared, like that. Okay, so how are we going to factorize this type of an expression, guys? Okay, we know that here the coefficient of a squared here is not a 1, so it's going to be difficult for us to apply that concept unless maybe if you interchange in terms of what? In terms of b. All right, unless you interchange in terms of b. But as we can see like this, the coefficient of a squared is not 1, so we are going to multiply the first term and the last term. So if we multiply the first term and the last term, 2 times 1 here, this one is same as 1b squared, so it's 2 times 1, which is 2a squared b squared. So remember, we are going to find 2 factors or 2 numbers that when we multiply, they are going to give us these 2a squared, b squared, but when you add now, it's going to give you the middle term, which is minus 3ab. So which numbers are we talking about here? Definitely it's minus 2 and minus 1. If we multiply these two, it's going to give us 2. If we add these two, minus 2 plus minus 1, it's minus 3. But we have to write these numbers in terms of what? A and B. So like I said, it depends with what you are going to use it like. All right, so this is going to be 2a squared. We replace this now into the middle term. Remember that long process of factorization, guys. So this is going to be minus 2ab. This is minus 1ab, but we know that minus 1ab, you can just write it as minus ab. Okay, it's fine. You can write it as minus 1ab, but even as minus ab like that. Okay, plus b squared. So we have replaced these two into the middle term, which is in place of what? Minus 3. Then we know that we are going to do this by what? By grouping. This is why we are doing this, so that we are going to separate this into 2 so that we can factor out the highest common factor here, which was going to be 2a, because a is common and the one with the smallest exponent is 2a. So if we divide 2a squared divided by 2a, remember this is going to give you a, because it's 2 and 2, 1. A squared divided by a is a, minus 2a and 2a is going to give us a 1 there, because it's going to cancel. Okay, there's a b there, so it's going to be minus b. All right, so remember guys, the reason why we separate is that we have to create another bracket which is the same as this one from these two terms. So what are we going to factor out? Definitely it's going to be minus b, so that it becomes a positive here. So if we factor out minus b, this was going to be positive a, and this is going to be b squared divided by minus b, which is minus b, like this. As you can see, this is a negative, this is so you are supposed to have the same bracket here, so that you factor out that bracket, which is a minus b. You are left with 2a minus b, like that. So this is what we had from the first expression. That expression, so it's going to be a over, we write those brackets that we obtained, which is a minus b. Remember, we obtained a minus b into 2a minus b. All right, so this is what we obtained. Plus, we do the same, we just factorize that one again. So let us just quickly factorize this to a squared plus ab minus b squared. So you're just going to do the same thing here, guys. Multiply the first term and the last term, which is now this time it's minus 2a squared b squared. So which two numbers, guys, that we have that we are going to multiply to get minus 2, but when you add, it's going to give you a positive 1. As you can see, this is a positive 1. So which two numbers are we talking about here? We have got minus 2 and 1. So let's try 2 and minus 1, because what we need at the end is supposed to be a positive 1 here. So if we multiply, yes, we are going to obtain minus 2. If we add 2 plus minus 1, yes, we are going to obtain a positive 1. So these are the two numbers. Take note, minus 2 and 1 is going to be wrong, because if you add this, it's going to give you minus 1, not plus 1. All right, so these are the numbers that we are going to replace in the middle term. So we are going to have 2a squared plus 2ab. So this is 2ab minus 1ab, which is minus ab minus b squared, which is the last term. So the first term and the last term, you just write them as they are. Then the middle term is the one that you replace with the two terms. Now we are going to do this. We are going to separate, right, like that, into 2. Then we factor out what is common here, and if we are to cross check here, 2 is common and also a is common, so we're going to factor out 2a. So it's 2a squared divided by 2a, which is a. 2ab here, take note here, 2 and 2 cancelled, a squared divided by a is a. So here it's the same, 2a and 2a will cancel, so which means we are going to remain with b. so it's plus b. Okay, here we want to make this bracket to be the same as a plus b, so we have to factor out this negative which is common, but it's negative what? Negative b, because b is common. So the moment we factor out this negative, it's now negative divided by negative, which is a positive. Okay, b and b will cancel, which means you are left with positive a. Okay, minus and minus cancel, b squared divided by b, which is plus b. So the brackets are now the same, so you factor out that bracket which is the same, then you are left with 2a minus b. This is what you are left with, 2a minus b. So it's a plus b into 2a minus b. Okay, so that's what we have this time. So it's b over a plus b into 2a minus b. Okay, plus the last part, it's already done. There's nothing that we can do there. All right, so that was the whole story on factorization. As you can see, the whole part there was on factorization, guys. And after that, we know that when we are adding like this, we need to find the LCD of all the denominators, which is we take all from all the denominators here. So we've got a minus b. Okay, we have got 2a minus b. It's also here, 2a minus b, 2a minus b. So you don't repeat, you just take it once. Okay, we have got a plus b here, a plus b here. So it's just appearing one time here, one time here. So you don't repeat, you just write it once like that. So that is our LCD. So remember, you don't cancel, you just assume as you are cancelling, because you are going to divide the LCD divide by this denominator, but you don't cancel anything, you maintain the denominator. Okay, so as you can see, if we divide this LCD and this denominator here, this a minus b will cancel, 2a minus b, 2a minus b will cancel, which means actually you are going to be left with a plus b, but it is going to be multiplied to the numerator where there is a. So it's going to be a times this part which is remaining, because this is cancelled, so you are remaining with a plus b. But you assume as if you are cancelling, you don't cancel now these two, no, you just assume cancelling these. All right, so it's the same thing here, plus b into, you divide again your LCD, divide by this. So as you can see, a plus b and a plus b will cancel, 2a minus b, 2a minus b will cancel, which means you are going to be left with a minus b. So this is going to be into a minus b. Okay, plus this LCD divide by a plus b. Okay, already there was a plus 1, so let's just write plus 1, then we multiply with whatever that you're going to get. So as you can see here, if we divide this a plus b here and this a plus b will cancel, but you don't cancel them, you just assume cancelling. So which means if we cancel this, we are going to be left with these two brackets, which is a minus b into 2a minus b. So you assume cancelling, you don't cancel this LCD, you maintain it. All right, you maintain it. So let's maintain it throughout. So we are going to have a minus b into 2a minus b into a plus b. We have to maintain this. All right, so what is going to happen is that, as you can see, guys, on the numerator you can actually expand. You can expand the brackets and simplify further. That's a times a, which is a squared, a times b, which is ab, like that. Okay, we are done. We move on to b times a. Yes, we're supposed to write it as b a, but already we have written this as ab, so we are going to write it as ab. So b times a is ab, so that we don't confuse ourselves now when we are collecting like terms. All right, it's one and the same thing, but write in a way that you don't confuse yourself. All right, plus b times minus b, so it's plus and minus, which is minus b squared. Take note, it's b and b, it's b squared. All right, here it's plus 1, which is going to affect a minus b, but we've got another bracket of 2a minus b, so we are going to expand a times 2a, which is going to give us 2a squared, and a times minus b, which is minus ab. Remember how you expand two brackets, guys. We are done with a, we move on to b, so it's minus b times 2a, which is minus 2ab, minus b times minus b, which is plus b squared, like that. So the moment you expand like that, you are now able to collect like terms. So let's see further if we are able to win here. Let's see how it is going to, what is it going to look like. So we have got these like terms. You have got a squared here, so this one is same as 1 a squared plus 2a squared, so it's 1 plus 2, which is actually 3a squared. Okay, so that is 3a squared. Okay, this one is same as we have got 1ab plus 1ab, so 1 plus 1, which is 2ab. All right, then 2ab and this minus 2ab will actually cancel, because this is 1 plus 1, which is 2ab, and this 2ab and this 2ab will cancel, which means you are going to be left with minus ab. All right, so we are going to be left with minus ab. Let's see for b squared. We have got minus b squared here and plus b squared. So as you can see, these two are the same. This is minus, this is plus, so these two will cancel again. So this is our final answer. Therefore, this is going to be our final answer. As we can see, yes, we can factor out a, or we can just leave it like that, because there's nothing that we are going to have at the end. So this is our final answer there. So that is what we had, guys. These are the stages that you are supposed to take whenever you are working with typical expressions, typical terms like this. That's what you actually need to have. So please, guys, make sure that you actually revise along the lines. Then on 2.12 we now given another part again with this time 4 marks, but as you can see, it's also a matter of factorizations. Again, it's also a matter of factorization there. So this time, what can we do? How can we simplify? Yes, we are multiplying and so on and so on, but what can we do? All right, if we are to cross-check actually on the first part here, before we go further, we can see that 4 is common here, because we've got 4, 8, and 4. So 4 is common there. We can actually factor it out before we go any further. So we are going to have 4p squared divided by 4, which is going to be p squared. 8 divided by 4, which is 2, so it's 2pq, plus 4 divided by 4, which is 1, so it's going to be q squared, like that. We are not adding or subtracting where we have to keep the denominators and so forth. Here we can factorize step by step, so that we see what's going to happen. So let's just do it stage by stage. All right, here also 3 was common here. If you are to cross check here, 3 is common, so you can factor out 3, which is p squared minus q squared, times we have got 9, 6, and 3. 3 is also common there. These are multiples of 3. So we are going to factor 3, which is going to be 9 divided by 3, which is 3p squared, minus 6 divided by 3, which is minus 2pq, minus 3 divided by 3, which is minus 1. So this is minus q squared, which is minus 1q squared or something like that. All right, and here 4 is common, so we can factor out 4, which is going to give us p plus q. So that's what we have. So at this stage, yes, we can now continue factorizing and so forth, but if someone could see that these are the same, so you can actually cancel this 4 and 4 because it's numerator versus the denominator, numerator versus the denominator, so you can actually cancel. So the next stage is actually not a matter of rewriting this now, but we can now factorize. All right, so now we can actually factorize here. Okay, so remember guys, here now the coefficient of p squared here is 1, so we can actually apply that direct factorization where we just going to write p and p here, and you focus with the last term, which is q squared. So since we've got q squared here, which means we have to find two terms that we are going to add to give us 2q. But if we multiply them, they give us q squared. But if we add them, they give us 2q. So definitely it's q and q. If we multiply this, it's going to give us q squared. If we add this, it's going to be 2q. 1 plus 1, that's 2q. So we are going to have plus q here, plus q here. Or you can apply that long factorization. Still, you are going to obtain the same answers there. Okay, and what about this part? This is clear difference of two squares because we are having squared and squared there, so we are going to have p minus q into p plus q. Remember, for difference of two squares, one subtracts, another adds. No matter the way, you can start by adding then subtracting. It's one and the same thing. All right, then here we've got 3p squared minus 2pq. So here we have to just factorize it aside. This one, 3p squared minus 2pq minus q squared. So as you can see, we are back. The coefficient of p squared is not 1. So we have to apply the long way. It's different from this one. The coefficient of p squared was 1. So you can just apply it direct. But this time, it's not. So we have to apply the longer way. So what are we going to do? Multiply the first term and the last term, just like what we did on those questions. So this is going to give us minus 3p squared q squared. So we need factors of minus 3 that we are going to add to get minus 2. So minus 3 and 1. Is that so? If we multiply, we are going to get minus 3. If we add, we are going to get minus 2. So these are the factors actually. So we are going to replace them into the middle term, which is minus 2pq. So it's minus 3pq plus, because it's a positive one, this one. So it's positive 1pq. So you just write it as pq minus q squared like that. So that's what you're going to have there. And you have to factorize again and again and again and again and again and again, so that we are going to have a resultant which is exact here. All right, so from this part, guys, what are we going to have? This is the question. What is common here? 3p. Okay, because you have to group them. So 3p. If we divide, here is going to be 3p squared divided by 3p, which is p. Then here, if we divide this, it's going to be minus first. Then 3 and 3 will cancel. P and p will cancel. You remain with q. So it's p minus q. So which means you have to find p minus q in another bracket. So which means you're going to factor out plus q, so that we obtain p minus q, because this is going to be plus and plus, which is plus. Q and q cancel, you remain with p. Okay, minus q squared divided by q. So this will cancel, you remain with minus q. So these brackets are the same. You factor out one once like that, you factor it out as one bracket like this, okay, into 3p plus q like this. So that's what you're going to have here from that part. So this is what you're going to write here. In place of this whole part, we are now going to substitute with p minus q into 3p plus q, 3p plus q, everything over p plus q. So this one is direct, there's nothing that we can do there. All right, so that's where we are, guys. Okay, so as you can see at this stage also, we are now able to cancel as long we have the same thing in the numerator and the denominator. All right, so let's do this, guys. P plus q can cancel. P plus q can cancel because the numerator, the denominator. P minus q can cancel, which means we are only left with 3p plus q. There's nothing that we have, and it's in the numerator, so it's 3p plus q over 1, which is just the same as 3p plus q. It's nothing that is going to change there. So that is what we have. Remember, guys, 2 over 1 is same as 2. So 3p plus q over 1 is going to give us 3p plus q. So that was actually what we needed there. This is what you need. The stages that you are supposed to actually take. All right, so I don't know if it is actually clear, but these are some of the steps that you need to have. Okay, but let's see this part, which is given the following algebraic expressions. We are given these. Factorize each expression completely, and we've got 7 marks for that. All right, so let's see how we were supposed to factorize each completely. The first one was minus 2n minus 2l minus 2n squared plus 2l squared, like that. That is what we had on the first one. So on this one, it's going to be actually difficult for us to like separate, and it is going to be difficult, but we can factor out minus 2, which is common here. All right, which is minus 2 divided by minus 2 is going to be positive n, minus 2 and minus 2, which is plus l, minus 2 and minus 2, which is plus n squared, plus 2 and minus 2, which is minus l squared, like that. All right, so this is what you're going to have. Now, as we can see that this is a difference of 2 squares, so we can actually have something like this, minus 2 into, because this is going to be n plus l, like this. We are going to have something like n plus l, let's just say in a bracket like that. Then plus this here, it's a difference of 2 squares here, where I told you guys you're going to have n minus l into n plus l, like that. So you simply take these 2 terms which are being under the squares. All right, but after having this difference of 2 squares, there's something that is happening here. We have got n plus l, which is common. So we can actually factor it out, n plus l. But I want you to see something, that the moment you factor out this n plus l here on this part, we are going to remain with 1, because like when you factor out, remember, you cancel this and this. So on this part, we are going to be left with 1, like this. If we factor out n plus l here, we are going to be left with n minus l. So it's going to be plus n minus l, like this. So we can actually write as 1 plus n minus l, of which there is nothing that we can do because this is 1, this is minus l. So that is the simplify that we had. There's nothing that we can do there. Nothing. There's nothing that we can do actually. All right, let's see another part. It's minus 2n minus 2l. Okay, so this one was a little bit direct. Minus 2n minus 2l. So minus 2 is common here. We factor out minus 2 is going to give us positive n. Minus 2 here is going to give us positive l, because remember, you just divide. Minus 2 divided by minus 2 is positive. Minus 2 divided by minus 2 is positive l. So this one was a little bit direct. Okay, let's see another one that we had. It's minus n squared minus 4nl minus 2l squared. All right, so I'm just going to maybe write it here. It's minus 2n squared minus 2n squared minus 4nl minus 2l squared, like that. So here minus 2 was also common, so we can factor out minus 2 first. Minus 2 and minus 2 is going to be positive n squared minus and minus, which is going to give us positive. So 4 divided by 2 is 2nl. Negative 2 and negative 2, which is a positive l squared. 2 and 2 is going to cancel. So as we can see here, we can just apply our normal direct factorization. Since the coefficient of n squared is 1, so we are going to have 2 brackets n, another bracket of n again. So since this is l squared, we need 2 terms that we are going to add to give us 2l. So this is l and l. L times l, that's l squared. 1 plus 1l, which is going to give us 2l, so it's plus l, like that. Of which you can write this as minus 2 into n plus l to the exponent of 2, since it is appearing 2 times. So you can actually leave it like that. So that's if you want to write it that way, because it's not like a forced matter. You can leave your answer on this previous stage, this one, or you can leave it here. Okay, sorry, I want this paper here. Okay, I want it here. So that was the first part. We've got 7 marks just to factorize, then determine the HCF and the LCM for all 3 expressions. Determine the HCF and the LCM. All right, so let's start with the HCF first. This is 2.22. Okay, so remember guys, I told you that the HCF must be common throughout. So these are the terms actually that we had. Okay, or maybe let me just do this. We obtained minus 2 into n plus l, 1 plus n minus l here. Okay, this is 1 plus. Take note guys, this is a 1 plus. And the other one we obtained minus 2 into n plus l, so that it can be easier for us. Okay, the other one, which is this one, we obtained minus 2 into n plus l squared. All right, so let's just do this. Minus 2 into n plus l squared. All right, so it's now easier for us to locate the HCF. Remember, the HCF should be common throughout. So as you can see, minus 2 is common throughout. N plus l, n plus l, n plus l is common. And remember, I told you that you take the one with the smallest exponent, which is 1. So our HCF is going to be minus 2 into n plus l, the one with the smallest exponent. So this bracket of 1 plus n minus l is not common. We do not have it here. We do not have it, so we don't take it for the HCF. All right, now we move on to the LCM, and remember that the LCM, you take everything that is common. Okay, so starting with minus 2 we're going to take it as, although it's common, there's nothing that we do because it's just appearing, same thing. But this n plus l, you take the one with the highest exponent. Okay, so we are going to have minus 2 into n plus l to the exponent of 2. Then there is a bracket, this one of 1e plus n minus l. It's also appearing, you take it as long the term, the bracket, the number is there. For the HCF, you have to take that bracket, you have to include that bracket in your answer as long it is there. But the HCF, remember, it's a common factor. You have to take what is common throughout. That is your HCF. I think this part was a little bit direct, if we can see properly. Then on question 3, actually is to solve for P in the following equation by using factorization method. So you're actually solving for P. Okay, so this is okay. So whenever you're working with a quadratic equation, remember, you might be given, in fact, this is what happened, you are given a method to use, not any method of your choice, but you are given a certain method to follow. So this time they want you to use factorization method. So remember, guys, here, whether we are using factorization method or quadratic formula or whatever method, we know that we can actually avoid to work with a negative. So that one does not affect the method that you are using. So you can divide by minus 1 throughout so that it can be a positive here. So it's going to be 3p squared minus, both is plus and minus, which is minus p, plus and minus, which is minus 2, is equal to 0. Now it can be easier for us to work with a positive term on the first term here, where we are going to multiply the first term and the last term, because remember that we are using factorization method. And as we can see, the coefficient of p squared is not 1. So we have to apply the long way of factorization, where we multiply the first term and the last term. So 3 times minus 2, which is minus 6p squared. So what are the two numbers that we multiply to get minus 6p squared? But when we add these numbers, they must give us negative 1p, which is the middle term, minus 1p. So definitely the numbers we've got minus 3p and 2p. If we multiply these two numbers, minus 3 and 2, that's minus 6. If we add minus 3 plus 2, that's minus 1, which is minus 1p. So these are the two numbers that we are going to substitute or to replace into the middle term, which is minus 1p. So we are going to replace with minus 3p plus 2p. All right, so minus 3p plus 2p minus 2 is equal to 0. The moment we are at this stage, it means we are able now to factorize. Remember how we factorize, guys. It's just applying the same concept of factorization, but remember you are solving an equation, so it's always is equal to 0, is equal to 0. All right, so here 3p is common, so you can factor out 3p, which is going to give us 3p squared divided by 3p. 3 and 3 cancel, p squared divided by p, which is p, minus 3p divided by 3, which is minus 1, like that. 2 is common on these two, so we're going to factor out plus 2, which is plus 2p into 2, which is p, minus 2 divided by 2, which is minus 1, is equal to 0, like that. So actually you are always writing is equal to 0 because this is an equation that you are using, although it is under factorization method, but it's an equation. All right, so p minus 1 is common, you factor p minus 1, you are now left with 3p plus 2, 3p plus 2, like this, we equate to 0. That is factorization method, where now we are going to use the concept because we are now left with two brackets multiplying each other. So from the zero concept, we know that this bracket is going to be equal to 0 and this bracket is going to be equal to 0. So we are having two things here in place of p. Either p minus 1 is equal to 0 or 3p plus 2 is equal to 0, like that. So we separate, this is equal to 0, this is equal to 0, like that. So what are we going to have at the end? P minus 1 is equal to 0. You transpose here, so it's going to be 0 plus 1, which is 1. So P is equal to 1. Or if we transpose this, is going to be 3P is equal to minus 2. We divide by P, 3 by 3. So P is going to be minus 2 because it's a negative there. So it's negative 2 over 3. So actually these are going to be two possible values of P. So this one was a little bit direct, something like that. So for V and W in the following simultaneous equations. So there it was up to you to choose the method because you are not told to use which type or which method. So there were so many ways. So what I'm just going to do is to use substitution because most of you are used to substitution, but there were so many methods actually that were that you could have used. 5v minus 2w minus 6 is equal to 0, like that. So we can just have this as our equation 1. Then our equation 2 is 6w minus 3v minus 30, which is equal to 0, like that. All right, so we remember we have many methods that we can use to solve simultaneous equations. So I'm just going to use substitution, the one that we are used to. So this is my equation 2. I'm just going to make v the subject on equation 1. So if I make v the subject on equation 1, that means I'm going to have something like 5v is equal to, if we transpose this minus 2w to the other side, is going to be a plus, minus 6 is going to be a plus also. So it's going to be 2w plus 6. Then we can divide by 5 by 5 like this. So v is equal to 2w plus 6 over 5, which is now our equation 3. So I'm going to substitute equation 3 into equation 2, not equation 1, because I made equation 1 the subject. So I'm going to substitute into equation 2. In place of v, we are going to substitute this fraction in place of v. So we are going to have 6w minus 3 times v. So you definitely have to open a bracket because you've got a fraction there, which is 2w plus 6 everything over 5, like this. So it's over 5. Okay, so we're going to close the bracket, and there's a minus 30 which is there, then we equate to 0, like that. All right, so as we can see, now we have an equation here which is actually in terms of w. Everything now is in terms of w. So what are we going to do? We can actually expand or clear the fractions. I don't know what is going to be best for you, but there are so many ways either that you can actually work with. So you can expand this fraction here because this is over 5. So multiply each and every term by 5, by 5, by 5, by 5, each and every term. That's going to give us 5 times 6, which is 30w, like this. Then this 5 and this 5, because it's in the numerator, this is in the denominator, so this and this will cancel. So you are now left with minus 3 into 2w plus 6, because this is cancelled. That the purpose of multiplying by 5 is for us to remove the denominator actually. So that part is going to be totally removed. All right, then we've got minus 30 times 5, which is 150, then 0 times 5, which is a 0 there. So expand brackets, that's what you have, or what you're left with, guys. There's no way. Minus 3 and 2 there, which is minus 6w, minus 3 and positive 6, which is negative 18, negative 150 equal to 0, like that. So collect like terms and so forth. 30 minus 6, which is 24. This is actually 24w. Minus 18 minus 150 is going to give us something like 168. That's minus 168, which is equal to 0 there. Then we can actually transpose this to the other side, which is going to give us a positive. So we are now having 24w is equals to positive 168. Okay, that's what we have if we transpose there. So if we divide by 24 by 24, actually we have the value for w, which is something like 7 there. So the value of w is going to be 7. So in order for us to have the value of v, it's going to be easier for us now to substitute it here. The value of w, which is 7, the one that you obtained, if you substitute it here on your calculator, your v is going to be a 4. So this is what you're going to have. Is going to be v is 2 into 7, which is 2 times 7, that's 14, plus 6 over 5, which is actually 20 over 5, which is 4. So that's what we had actually from this part. As we can see, just to solve a normal equation. Then on 3.3 we are now given another consideration that a boy pays with 30 rand. So you are making a payment with 30 rand there for 4 plums and 2 guavas and receives 2 rand change. Okay, calculate the price of palm if a guava cost 2 rand 50. So this is the case here that let's start with knowing the amount of money, the amount that was actually used before we talk about anything here. This is a 30 rand in pocket or 30 rand. Then if there is a 2 rand change there, it means we are going to subtract that because it's a change, this one. So we want to know the amount which was used, which is actually 28 rand, if you're not mistaken in terms of calculation. So this is the money which was used to buy all these. We used 28 rand. So out of 28 rand, we have each guava which cost 2 rand 50, and 2 of them were bought. So which means how much was used to buy these 2 guavas. So we are going to have this as each amount 2 rand 50 multiplied by 2, which is going to give us 5 rand. So that means if we used 5 rand to buy all these guavas that we had, how much did we spend to buy just each palm? Because we are given that 4 palm in this case are the ones that we bought. So we need to know the amount for all of these 4. So where are we going to get the amount of all these 4? Since we know that this is the money that was used to buy everything, and so far we said 5 rand is the one that we used to buy all these guavas, is 5 rand. So it means for the plums that we are left with is going to be 28 rand minus 5 rand, which is going to be 28 minus 5, which is 23 rand. So this is the amount of all the palms that we bought. But in this case, we need to calculate the price of a palm, which means we're talking about each, which is 1. That is each. and we bought how many? 4 of them. So what is going to be the cost of each? Okay, so which means each poem, in this case definitely we have to divide. How many do we have? We've got 23. Divide by how many did we buy? It's 4. So if we divide by 4, which means each is going to be 5 rand 75. So that was the cost of each gram. So that's how, guys, they ask these questions. So you have to be very, very careful when attempting questions. Okay, so these stages, they are very, very important when you are attempting questions and so forth. All right, then on 3.4 we are then make p the subject of the formula. All right, so that is it there, to make p the subject of the formula, which is 3.4 one, where we are actually given something like mn is equal, that was the 5th root, guys. This question was actually something else. It's actually something else, guys. All right, let's see. This is it, what we have, and we want to make p to be the subject there. Okay, and look where p is, guys, how it is surrounded by all these terms. So what can we do? Okay, let's just maybe start by cross multiplying, so that at least we can remove some other terms which do not have anything to do with p. Okay, so you can cross multiply. So if you cross multiply this and this, we're going to be m and m, which is m squared. Okay, we've got n and q, so it's going to be nq, which is going to be 1 times this, which is going to be the 5th root of everything there, t to the exponent of 3 minus p to the exponent of 3. So this is actually the 5th root that we are given. So how can we remove this 5th root that we are given? Just like what you do to the square root, you square. So this time is the 5th root. You have to raise to the exponent of 5, which is the number inside the root sign. So it's to the exponent of 5. But what you do on the right hand side, you have to also do it on the left hand side, because it's an equation. You have to balance the side. Whatever you do on the left, you do it on the right. Okay, so that means definitely here we are going to have 2 times 5, which is 10. So it's m to the exponent of 10, n to the exponent of 5, q to the exponent of 5, because this is just like 1 and 1, so it's 1 times 5, 1 times 5. Okay, but here we have removed this by raising to the exponent of 5, which means we are going to be left with these 2 here under the square root, which is t to the exponent of 3 minus p to the exponent of 3. This is what you're going to remain with. All right, remember, sorry for that, remember you want to make p to be the subject, and look, the part with p, it's a negative. So how can we avoid this? We can transpose it to this side so that it can be p to the exponent of 3, which is a positive, which is equal to t to the exponent of 3. Then we transpose this now to where p was. So it's going to be, it was a plus, so when it is here, it's going to be minus m to the exponent of 10, n to the exponent of 5, q to the exponent of 5, like that. So that's what you had, and you have to remove this, the cube root, just like what we did there. So now you introduce the cube, because it's an exponent this time, so you introduce the cube root both sides. So it's going to be cube root also there. So the moment you introduce this and this cancels, you are left with p. So therefore p is going to be the cube root of everything there, which is the cube root of all this part. There is a 3 inside there, so it's the cube root of t to the exponent of 3, m to the exponent of 10, n to the exponent of 5, q to the exponent of 5, just like So actually that's what you need, and you just have to substitute properly whatever information there on to calculate the value of p. Now on 3.42 we are given that using that value. Now what is this? So we just have to substitute all those values as they are. This is 3.42, so if you substitute properly it's going to be something like this. The cube root of t, t is 1, we're given 5.2 m, so you just substitute these values in place of each. So t there, it's 5,2, exponent of 3 minus m, which is 1,35, to the exponent of 10, that's n, or n 0,25, exponent of 5, your q, which is 2,75, to the exponent of 5. So you just have to put everything properly on your calculator, and this is going to give you a decimal, which is 5,16, or 5,16,1648 and so forth, which is 5,162 to decimal places. So that was actually just 1 mark there. So guys, as you can see, it was just a matter of proper substitution there. All right, then now on question 4 we are given that a spherical, which means we're talking of a sphere lead, you know, a sphere like a ball, okay, metal, which is now it's a ball actually, is made by melting conical, which means it's a conical shaped lead, perpendicular height. We are given the height. So here we've got two things, guys: a cone, a sphere, and a cone. Actually, a sphere and a cone. Given that both shapes have the same radius, calculate the following. Take note, guys: the sphere and the cone, they have the same radius. So calculate the base radius of the conical lead, which means the radius that we are calculating is the same radius on the sphere. All right, so how can we end up with this? And we are only given the height. This is the only thing that we have, the height of a conical sphere. Okay, so this is the concept here. These two, they have got the same radius. Okay, same radius. Also their volumes is also the same. Why? Because this spherical ball was made by melting the conical shape, so the volume is the same. There's nothing that changes by melting. So we are going to have the same volume, which is the volume of a sphere. Remember, the volume of a sphere on your formula sheet, it's 4/3 pi r cubed, which is equal to the volume of a cone, a cone, a circular cone, which is a cone, which is a third pi r squared h, third pi r squared h. This is what we had, something like that. All right, so these two are the same, and we are given the height is what is 12 centimeters. We have the height, which is 12. That is the only thing that we have, guys. So you can actually play around from this part, because this h we have it. All right, so as you can see, it's just something easier, because here if you are to cross check pi and pi, because it's now an equation, so you can cancel here. Pi and pi is the same. Okay, if we divide by r squared here and r squared, we are going to remain with r here. So we are going to remain with 4r/3, which is equal to, we have got 1/3h. So it's 1/3 times h, but we have got the value of h here, which is 12. Okay, take note, the height is 12. So our height is there, which is 12, and this actually can cancel. I don't know how you can do it, but this can cancel. Anyways, 1/3 times 12 is 4. So you're going to have 4r/3, which is equal to 1/3 times, which is 4. And this is just same as 4/1, where we can actually cross multiply, or just like what we did to cancel pi and pi. Do you see it's the same thing between 4 and 4? So you can actually cancel this 4 and 4. You are just left with r over 3, which is equal to 1. So you can just cross multiply, which is r is equal to 3 times 1, which is 3. Or even at this stage, you could have done the same thing, 1 times 4, which is 4r is equal to 3 times 4, which is 12. Then you divide by 4, you divide by 4. So r is going to be 3. There are so many ways of working maths, guys. So many ways. So some of the ways we don't even talk about them, but there are so many ways that we can use to solve typical questions. Okay, anyways, let's see this part now, where we are given now to calculate the surface area of a conical lid in square centimeters. Take note now, we are working with a conical lid and we are calculating the surface area. So I just want you to see from your formula sheet that we already have these formulas here. If you are working with a cone, the surface area is given as pi r l plus pi r squared, of which l is same as h squared, square root of h squared plus r squared. So which means we have to find that, or we can just substitute direct our surface area, which is going to be pi r into h squared plus r squared plus pi r squared, which is the same thing as pi rl, okay, plus pi r squared. So we have to find this l here, which is going to be found by this. So if we are to find it, then it's fine. Or since we have got h, and you can just substitute, so it depends with what you want, guys. Okay, so pi times r, which is the radius, we just calculate it now. Where did I put that? Okay, it's here. We obtain 3. Okay, our radius was actually 3 here. All right, so it's going to be 3 times the square root of this, which is going to be something like this, square root of h squared plus l squared, which is going to give us l. So h, remember the height, we were given the height before that. The height is 12. The height is the one that we were given originally here, which is the perpendicular height is 12. So that's going to be 12 squared plus r squared, which is the radius that we found, which is 3 squared. So this is your L, which is the slant height. Take note, L represents the slant height. So this is going to give us something like 12,369, something like that, 369,31688, yeah, something like that, which is 12,369 centimeters. So I don't know if there's any part that we see which is not clear. Let us talk, guys, on the comment section there. So it's 369 like that. Okay, plus pi r squared. Remember our r is 3, so it's going to be pi 3 squared. This is squared, not r cubed. So it's now a matter of you guys and your calculator to simplify properly, but we are going to obtain 144,84941 to something like that, which is actually 144,849, and this is actually square centimeters because it's area, guys, is measured in square centimeters. All right, so that's what we had, and another part is now to calculate the surface area of the spherical ball in square centimeters. So this is the surface area of a sphere, which you are also given that the surface area of a sphere is 4 pi r squared. So remember that these two, they have got the same radius, so we are going to use the same radius there. So area, which is our surface area, is 4 pi r squared, so it's going to be 4 pi times r squared, which is that radius, 3 squared. All right, so this is going to give us 36 pi square centimeters. All right, so that's what you're going to have. But if you are to write it as a decimal now, that's where we are going to have it as 113,0973355, something like that, which is 113,097 square centimeters. So that's how you can now actually write your final answer or your final presentation, because it depends, because you are not given how to give your final answer, so you just write in a way that you understand much better. Use mid-ordinate rule to calculate the area enclosed. Remember the mid-ordinate rule, guys. You are also given the formula for that mid-ordinate rule, that the area is the first ordinate plus the last ordinate over 2 plus sum of other ordinates times the common distance between. All right, so we have to find this area, which is on 4.2. So our area is going to be the first ordinate. Remember, we are going to have first ordinate, it's 3, followed by 5, 7, 10, 16, 11, 9, and so on. So these are the ordinates that we're talking about. The x is there to give you the values of x. They are the ones which give you the interval, the distance between the points. Okay, so which means this is your first and this is your last. So 3 plus 8. All right, so it's first ordinate plus last ordinate over 2 plus sum of the remaining. So these are the remaining that you have to add. So you close the first and the last, those ones. So you add these numbers that I indicated in towards 5, 7, 10, and so on. So it's 5 plus 7 plus 10 plus, this is 16 plus 11 plus 9. Plus 16 plus 11 plus 9. So that's what you're going to have actually. Then whatever that we get here, we multiply now by the distance between. As you can see, for x, this is 0 here, this is 2, 4, 6, 8. So as you can see, there's a difference of 2, 2, 2, 2. This is 0, 2, 4. So there's a difference of 2 there. So that is the distance between. So we multiply by 2 units. So if you add 3 plus 8 over 2, which is 11 over 2, which is 5,5. So you're going to add 5,5 up to this number here, which is going to give you 63,5 times 2, and this is going to give us 127 square units. All right, so this is actually our area in square units. All right, so guys, as you can see, that's what we actually had on that question, and that's it. Total of 10 marks just for that. Given the functions of f of x and gx, calculate the equation of the axis of what? Of the axis of symmetry of f of x. Okay, take note, guys, about the axis of symmetry, that it is equivalent from our f of x there, which is equal to 6 plus x minus x squared. It is at x is equal to minus b over 2a. That is the equation of the axis of symmetry. So here's just a matter of substitution. So it's going to be x is equivalent to minus b, the coefficient of x here, which is minus 1 over 2 times a. Remember, a is the coefficient of x squared, which is minus 1. So it's 2 times minus 1. So it's going to give us 1 over 2. So it's actually x is equal to 1 over 2, which is positive, or 0,5. X is equal to 0,5, depends with how you are going to answer it. Then calculate the y-ordinate of the turning point. Remember, at the turning point, the y-ordinate corresponds with the value of x at the axis of symmetry. So 5.12, we are going to substitute the value of x that you have obtained into this function. So it's going to be 6 plus x minus x squared, of which our x is 1 over 2. So 6 plus x is 6 plus 1 over 2 minus x squared, which is half squared, and this is going to give us 6,25 from 25 over 4. So this is the value of y, or 6,25. So that is the value of y at the turning point. So that was the question actually. Then we just have to move on, use the graph paper now to draw the graph of f of x and gx on the same system of axes. Okay, so for you to draw these graphs, it's actually easier for us because so far what we only have here is on f of x. On f of x, the only thing that we have so far is the turning point. That's the only thing which makes sense, because we calculated the value of x at the turning point, which was 1 over 2, and the value of y at the turning point, which is 25 over 4, which is actually 0, 0.5 and 6,25, something like that. You can just write it that way. That is the only thing which makes sense so far, but we need to draw this graph on a graph paper, and we don't even have the x-intercept, y-intercept, and so forth. So actually we have to determine those. Okay, so let's just find our x-intercepts. Okay, so x-intercepts, we know that x-intercepts are at a condition where y is equal to 0. So when y is equal to 0, it means this is equal to 0 here. 6 plus x minus x squared is equal to 0. So that's a normal quadratic equation that you need to solve. So you can just maybe start by writing it as minus x squared plus x plus 6 is equal to 0, like that. All right, so you can divide by -1 throughout, so that you can avoid working with a negative term here. So it's going to be x squared minus x minus 6 is equal to 0, like that. So depend with you're using factorization or you're using whatever method to solve. But if you're using factorization, coefficient of x squared is 1, so you're going to have x and x. Then what are the two numbers that we have which are going to give us -1, but from -6? So this is actually -3 and 2. -3 and 2. So it's -3 and plus 2. So it means x is 3 or x is going to be -2. So therefore, these are the values of x at the turning points at the x-intercept. Then we've got the y-intercept, which is at x is equal to 0. And by just looking at this function that we have here, if we substitute x is equal to 0, we're going to be left with 6. So definitely y is going to be 6 there. If x is equal to 0, y is going to be 6. So the y-intercept is there, the turning points, the turning point is there, the x-intercepts are there. Now at least it can make sense for us to sketch this. It can make sense. So what you just need is to make sure that you just divide your graph into a proper way. Okay, then you mark your points properly. In this case, the points that I'm going to mark are the x intercepts, which is 3 and -2. So I've got 3 and -2. Okay, yeah, that's 3 and -2. 3 here and -2 here. Okay, then I'm going to mark the y-intercept, which is at 6. Y-intercept here at 6. Okay, then I'm going to mark the turning point at 0, 0.5, 6,25. So 0, 0.5, somewhere between 0 and 1. Okay, yeah, in between. So it's gonna be somewhere 1, 2, 3, 4, 5, 1, somewhere here. So what you just do, you just mark in a way that you understand according to the scale that you have given or that you have drawn. Okay, then you smoothly join these points so that we can at least have a curve. So actually it's not something much, guys. This is just for you to be aware of what you're having. So I don't know, guys, and I'm using a pen, so any mistake, guys, is going to affect me. There's a turning point here, so it has to go back. That's our turning point, guys, here, and it has to go back to 6. So I don't know how am I going to win here. How am I going to win? Because all right, so that's like this exactly. So that was going to be your graph there. So that's what we had. And the major points is -2, 3, 6, and the turning point. These were the major points. So this one was just going to be 0,5, 6,5. Is this 6,5 or 6,25? Yeah, something like that. So that was what was going to be measuring your graph there. Then we also have a straight line, because these are two that we need. We also have a straight line. So on a straight line, we are just going to find the x-intercept and the y-intercept there. So it's going to be easier this time. So it's just gx is equal to 2x plus 1. So the x-intercept, we know that y is equal to 0 there. So when y is equal to 0, this is going to be like this. So it's going to be 0 is equal to 2x plus 1. So it's going to be -1 is equal to 2x divided by 2 by 2. So x is going to be -half, which is -0,5 or -half. Okay, that's the value of x. Then for the y-intercept, I know that x is equal to 0 there. So if x is equal to 0 here, y is equal to 1. All right. So these are the points that I need to mark so that I can have my graph at the end, which is x minus 0,5. X minus 0,5, which is 1, 2, 3, 4, 5. That's our x here, which is minus 0,5. And our y, which is at 1. So y is at 1, which is in between 2. So it's going to be 1, 2, 3, 5, somewhere there in between. That's where we have these 2 points. So these 2 points, they are enough. They are enough for us to draw a straight line. So you join these 2 points here, these 2 points, you join them with your ruler. It gives you a straight line. Okay, by doing that, it gives you a straight line like that. And this straight line is supposed to join also here, something like this. Okay, just like that. So this is our f of x here, and this is our gx. So these are the two, something like that. All right, so now because of the graph that you're using, but here I'm just like giving you what it was supposed to actually look like, so forth. And now use the graph to determine the values of x for f of x minus gx minus f of x is equal to 0. So there it's simply, if you transpose this, it is going to give you, if you transpose this, it's going to be gx is equal to f of x. So you're simply saying gx and f of x, they are equal. So remember, when they are equal, that is the point of intersection. This is where you take your answers. Your answers are going to be taken from the point of intersection of the graphs. Where these graphs meet, you draw dotted lines, or you just mark some lines back to the, I don't know if it is going to be clear, guys. So you just mark these dotted lines to the back to the x-axis. Okay, then you do the same here back to the x-axis again, like that. So these are your solutions in the x-axis here. So it depends now with the curve, but according to what we have, is going to be 1, 2, 3, 4, 5, 6, 1,6. So it depends with also the smoothness of your graph and so forth. So a lot of things are to be considered there. But according to this one that you're having, it's actually 1,6 there, or another one, -2, it's gonna count 1, 2, 3, 4, 5, 6, 7, -2,7, somewhere there. So you just take your values, but I hope you see what I'm saying. You take your values in the x-axis according to the scale that you're given. So also the graph that you're using and so forth, the smoothness is going to depend also on the effect. It's going to affect your answers also. So I don't know let's see, but I just hope you understand what will be happening there. Okay, so anyways, let's see another part here where we are now given use the graphs in question 5.13 to determine the values of x for which f of x is equal to 4. So this time we are saying that f of x is equal to 4. Where is our f of x equal to 4? This is our f of x, which is this graph here. So when it is equal to 4, you simply need to have the line of it at 4 here. So when f of x is equal to 4, that's you draw a straight line at y is equal to 4 like that, this one. Alright, that's where you have your answers, where y is equal to 4 there. So your answer is going to be where these two meet. You draw your dotted lines again back to the x-axis, where at the point of intersection, back to the x-axis, where these two intersect here, back to the x-axis again. So I don't know if it is going to be clear. Is it here or is there? But it's somewhere here. So now, like I said, guys, it depends also with your graph. So this one here is going to be at -1. This is -1, and here is going to be at -1 at 1,7. Yeah, so it's -1 and 1,7. So it depends with the graph that you are using, the graph that we had. It depends. So actually, if it is smooth, then your answers, they are going to be within a certain range. It's not a direct answer that you're going to have. In fact, this type of a question is not supposed to have one answer, because it depends with the smoothness of the graph. It's not supposed to be something like you're supposed to have it this way. No. Okay, then also there we are given the functions of h of x, hx and the kx. Use the graph paper to draw the graph of hx and kx. So just like what we had, guys, we have to draw the graphs of hx, which is here it's best for us to have a table. It can help us a lot. Hx is equal to 2 sine x. Remember, guys, I talked about trig when I introduced the issue of having a table that you can use to end up with these values. So you can have the values of x and the values of y there. Alright, so simply, guys, we just need the values of x and the values of y. And for sine and for cos, it's best to use 90 degree. And therefore, so you're going to use 0, 90, separate with a step of 90. So it's going to be 180, 270 there. If you add 90, 270 plus 90 is 360. So you add 90, 90, 99. Okay, so on your calculator, we are going to substitute 2 sine 0 there in place of, make sure that your calculator is in degrees. Alright, so 2 sine 0, that's S0. 2 sine 90 in place of x, you substitute 90, it's going to be 2. 2 sine in place of x, you substitute 180, it's going to be a 0. At 270 minus 2 at 360, a 0 like that. So it means we can have our graph there. Alright, the same thing you do for kx, which is equivalent to negative 2 cos x. So it's negative 2 cos x. So you do the same thing. You need to have your table. It's cos. It uses the same interval with sine. So 0, 90, 180, 270 here, 360 there. Alright, so the same thing. So when x is equal to 0, you substitute your 0 here, which is going to give you minus 2. When x is 90, you substitute 90 here, which is going to give you 0. When x is 180, you do the same, plus 2, 0 there, minus 2, and so on. So let's have our graphs. Let's have our graphs, guys. All right, this is what I have here. Okay, so the first one, it's 2 sine x. We're going to mark the points. Actually, we know these guys. I talked about this in our revisions. So it's 0 versus 0, 90 versus 2. So 0 and 0, that's this point here. 90 versus 2. So take note, guys, 90 and 2. So it's 90 degrees here and it's 2 here, guys. Look where we are going. Okay, 180 versus 0. So it's 180 versus 0 here. 270 versus minus 2. So it's 270 and minus 2, which is here. All right, 360 and 0, which is here. All right, so this is for 2 sine x. So it's going to be from this point, sorry for that, to this point. It comes back to this point here at 180. It goes to this point. It goes back to 360 there, something like that. So that was actually our hx, which is equivalent to 2 sine x, something like that. Okay, so you just need to be okay with that. Okay, so let's see another one. Kx, which is negative 2 cos x. Negative 2, with this is 0 minus 2. So this is going to be 0 minus 2 here. That's 0 minus 2. Okay, 90 versus 0. 90 versus 0 here. That's 90 versus 0 here. 180 versus 2. 180 versus 2 here. That's 180 versus 2. 270 versus 0. 270 versus 0 here. And 360 versus minus 2. 360 versus minus 2, like this. All right, so remember, guys, what we are supposed to have, like from the graph, of course, we're supposed to have something like this, actually, something like this. But now we are starting from negative values, so the turning effect also is going to affect, which is something like this. Okay, we go with this to 90. So it's now like the opposite of that one that we are used, something like this. Okay, it goes back to 270 versus 0 there, 270 versus 0, 360 and minus 1, something like this. Okay, so something like this. So that's how it is going to actually look like. So this is for kx, which is equivalent to negative 2 cos x. So that's how these graphs actually were supposed to look like. And I just thought maybe if I could but maybe I don't know now if this is gonna affect now, so that they can just be slightly different. Okay, but I think it's clear, guys. I think it's clear, and it's something like this. Alright, so I think it's we can clearly separate between the two graphs. So this is our first one for sine, and this one for cos. All right, so this is actually what we had from this part. And let's see another question what we had. Now it's use the graphs. Okay, from the graph A above, read the values of x for which hx is equal to kx. So just like the previous question, when the two graphs are equal, that is the point of intersection. Okay, so your answers are going to be taken from the point of intersection of the two graphs, which is at this point of intersection there, in between there. That is our point of intersection, guys. All right, Then also in between here, that is our point of intersection there in between. All right. So in between is 45 degrees, 45 degrees. So it's going to be 90 plus 45, which is something like 135. So we are going to have 135 degrees there. And another point of intersection is going to be here, which is 270 plus 45, which is actually 315. 270 plus 45, which is 315. So somewhere there. So 315 degrees. So these are the points of intersection actually that we have when these two are equal. At this point and at this point, where that is where they are equal. That is the point of intersection. So you just sometimes analyze with the graph that you are given. So that's actually the concept that you have there, that we had. And the other question is to convert 102 degrees 42 minutes to decimal radians. Okay guys, take note about this type of a question, that we can only convert to radians provided that this is totally in degrees, because we know the conversion of converting degrees to radians. So we have to convert this first to degrees, which is 42 minutes, of which 42 minutes to degrees, we know that 1 degree is equal to 60 minutes. So we have to divide 42 minutes divided by 60 minutes, which is going to give us 0.7 degrees. So this is 102 degrees plus 0.7 degrees, which is going to give us 102.7 degrees. All right, so this is in degrees, but our answer, we need the decimal radian. So remember the conversion, guys, that I always told you that if you are given degrees, you can use this conversion. Theta in radians is equal to theta in degrees over 57.3. So our theta in radians is going to be that theta in degrees, which is the resultant of the two, which is 102.7 degrees over 57.3 radians. This is going to be in radians automatically, which is going to be 1.792321, something like that, which is 1.792 rads. So this is now in radians. Or you can simply use the conversion that pi is equal to 180 degrees. What about 102.7 degrees? What do we have in radians? Because this is pi radians degrees. So you can use this conversion again. You are going to obtain the same answer, which is 102.7 over 180 times pi. You are going to have the same answer from there. So simply you can actually do that. So that's what we had on 6. This is 6.1, not 6. Where am I getting 6.2 from? This is 6.1, guys. Okay, then on 6.2 we are given a circular piece of cheese with an area of 240 square centimeters is divided into 5 equal sectors for a family of 5 at breakfast. So calculate the area of each sector in square centimeters. Actually there you just need to divide, guys, because we are given that each sector, the area of everything is 240 square centimeters and is divided amongst 5 members of the family. So if you divide by 5, which is going to give us something like 48 square centimeters there. All right, so that is going to be the area of each sector. All right, so now calculate the radius of each sector if it subtends an angle of 0.95 radians at the center. All right, so we have the area of this sector, guys, and we know that the area of the sector actually is given by this half r squared theta. So the area is there of each sector, because we calculated now the area of each sector, and we said each sector is going to have an area of 48. So you can actually formulate an equation, say that 48 is equal to half times r squared theta, where theta is the angle in radians that we are given. Theta, take note, guys, must be in radians, which is 0.96. So play around with your equation to find r there. That's it. So you can actually remove this cross multiply. It's gonna be times 2 times 2, so that this is gonna cancel. So it's 96 is equal to 0.96 r squared. So like I said, there are so many ways of solving equations, guys. Divide by 0.96, divide by 0.96, so this is gonna cancel. R squared is equal to, if you divide these two, it's going to give us 100. And to find r, definitely you have to introduce the square root, and this is in centimeters because we are given the area in square centimeters. So therefore the radius is going to be in centimeters, something like that. Okay, a wheel diameter 250 centimeters is a peripheral velocity of 275 meters per second. Calculate the angular velocity in radians. Wow, this is actually the formulas you'll be given, guys, about this. And let me see if I'm still having it here. If I'm not having, before I'm just gonna take them. All right, so anyways, I don't know how did I end up losing the other part of the formula sheet here, but anyways, okay, it's there. Okay, so that maybe it's easier when I'm having this from you guys. So this is what we have here whenever we are working with the angular velocity. These are the formulas that you'll be given, but we do not have anything that is going to link here, because what we have got the velocity in meters per second. All right, and what we need is the angular in rad per second, and here we do not have the relationship that we can actually use. But we know that from our circle there, from the definition of a circle, we talked about the radian concept and also the conversion that we have between rad per second and meters per second. And what is that conversion? The conversion is V is equivalent to, so this is a 6.31. V is equivalent to the radius times the angular velocity in rad per second. From angular to linear, you multiply by the radius, which is supposed to be in meters. This is the radius, this one. But we need this angular, this one is the one that we need, the angular velocity in rad per second, because we are given the linear. So we are going to divide by what? By the radius, So this is what's going to happen. So our W is going to be V over R, which is the velocity, peripheral velocity in meters per second. This one, 275 over the radius, which is in meters. There we have got the diameter in centimeters, so we have to find the radius, and remember radius is diameter over 2. So the diameter there is 250 and over 2, which is going to give us in what? In centimeters, or let us just have it in meters direct. This is going to be 2.5 meters, because this is in meters like that. All right, so 2.5 divided by 2, which is going to give us 1.25 in meters. Or you obtain another way, but that is what you are going to have. It was going to be 2.50 there, which is exactly, then divide by 2 exactly. So this is your radius here in meters, which is 1.25 like that. All right, so which means we are going to obtain, if you divide, that will give us 220. Yeah, this is rad per second. Remember, this is angular velocity, which is measured in rad per second. So that was it, guys. And the angular displacement in 1 minute. So the angular displacement, remember, that's the theta, and theta is omega over t, which is angular velocity over time. So this is 6.32 theta is what we are going to have from our theta, which is the product actually there, but we are given also this. So this one is going to be product, because remember omega is theta over 2 like this. So if you cross multiply, it's going to be omega t, but this time is supposed to be n seconds like that. All right, so the omega is the one that we just calculated, which was 220 there. So we are going to have 220 in rad per second, which is multiplied to the time in seconds, 1 minute in seconds, which is going to give us 60 seconds, and this is going to give us 13,200 rads. So this is actually measured in rads. Theta, the angular displacement, is measured in radians. Okay, then the height of the segment of a circle is 16 centimeters. The length of the chord is 4 centimeters. Calculate the radius of the circle. Okay, and we know that from our formula here we do not have the radius of a circle. We are given the diameter, where h is the height of the segment, x is the chord, and d is the diameter. So to find radius is going to be diameter over 2. So you have to calculate the diameter. Okay, so we are going to calculate the diameter, then we just divide by 2. So this is 6.4. So we say diameter is equivalent to h plus x squared over 4h, where h is the height and x is the length of the chord. So we just need to substitute here, guys, and the height is 16, so d is going to be 16 plus x squared, which is 4. So you've got 4 squared over 4 times 4, which is the height. The height is 16, guys, not this way. Yeah, so it's 4 times 16. If you do proper substitution here on this formula, because the formula is here, so this is 16 there. Okay, so we are going to have 16 plus to simplify this properly, which is going to give us 0.25 or 1 over 4. So it's going to be 16.25 as our diameter, but we said we need the radius. So the radius we said is diameter over 2, so it's 16.25 over 2. This is in centimeters. So if we divide by 2, this is going to give us 8.125. So this is going to be 8.125 in centimeters. That is now the radius. So take note, the question needed us to calculate the radius, but from the formula there is no formula for radius, is diameter. So maybe you could have just written as over 2 everything on this formula. You just say radius is equal to h plus x squared over 4h like this, everything over 2. Yeah, maybe that way it was going to make sense. So it's so as you can see, maths, guys, it's a matter of playing around with the formula that you are given in exam and so forth. Okay, then on question 6.5, which is actually going to give us 6.6 to make it 20 marks, which is 100 there. We're given that if sec theta is minus 5 over 4 and also the quadrant is between 180 to 270, without using a calculator, determine tan theta times cos theta. Okay, this is actually sec, and it's in between 180 to 270, which means we're talking about the third quadrant in this case. Remember, 90, 180, 270. So between 180 and 270 is the third quadrant, but we have to write this in a normal trig that we are used to. Remember, sec is 1 over cos, so sec theta is minus 5 over 4, and this sec theta here is same as writing as 1 over cos theta, which is equal to minus 5 over 4. So if we are to find cos theta, so cos theta is going to be the inverse of this, which is minus 4 over 5, because it's simply 1 over this, so it's the inverse. Or you can cross multiply find cos, make cos the subject, or just interchange. This is your cos. So you have written it in a normal trig that we are used to, where we know that cos is adjacent over the hypotenuse. So if cos is adjacent over hypotenuse, therefore we are going to locate the quadrant that we are told, which is the third quadrant. We just place our diagram here. Remember, our triangle is going to be like this in third quadrant. This is your theta here, and cos, we said adjacent over the hypotenuse, and this is the adjacent -4, the hypotenuse 5. So therefore we know that, guys, we have to find the third side. Apply your Pythagoras theorem. 5 squared is equal to minus 4 squared plus x squared. Let's just say this is your x from c squared is equal to a squared plus b squared. So that's going to be 25 is equal to 16 plus x squared. Transpose this to this side is 25 minus 16 there, which is equal to x squared. So x squared is 25 minus 16, guys, which is going to give us 9. Then the square root of 9, which is plus or minus 3. So this is going to be a -3 because of the region. That's what we have there, guys. All right, so now the question is, from this triangle that we have, what is tan theta times cos theta? So remember tan, guys, from your soccer tour. Okay, tan, it's opposite over adjacent. So tan theta times cos theta is going to be like this. Tan theta, which is opposite over adjacent. Okay, so this is going to give us opposite. This is in the negative region, this one. So tan theta is -3 over the adjacent, which is -4. According to this, this is your opposite. According to theta, this is adjacent, so it's going to be positive. Okay, so this is actually a positive, times cos theta, of which cos theta is the one that helped us to draw this diagram. If you used to remember where we interchanged that time, we said cos theta is -5 over 4. This was -5, 4 over 5, -4 over 5, which was the inverse of what? Of sec. So this is gonna cancel here, which is going to give us -1 over -3. In fact, because it's -1 times 3, which is -3 over 1 times 5, which is 5. So it's going to be -3 over 5. So that's what we have, and also to know that this quadrant is actually for what? For tan. So tan was going to be positive here, then because of cos, which is negative, it becomes a negative again. All right, so that's how some of these questions look like. So, and we are given a signal tau AB. We are given this one, it's a signal tau which is fixed on top of BC, the building, and we have given the two angles of elevations, 35 and 40 degrees respectively. Then if the height of BC, which is the building, this one is 150, then what is the length of the signal tau AB? Okay, so this is it, guys. This is what you're going to do. I'm going to separate these triangles here. We are going to calculate this, so it depends with how you want to do it, but as for me, I'm going to calculate this way. We are going to calculate this DC here, okay, using this smaller triangle, because we are given everything on that smaller triangle. Okay, so we are going to take this triangle like this. Our smaller triangle is BD to C. Okay, so it's BD to C. This BC, we have got it. We are given that from B to C here it's 150. So you've got 150 meters, and this is the angle here from B to D to C. This angle is 35 degrees. So you're going to use 35, not 40. Okay, because if we can calculate DC, it means we can be able to calculate AC. And if we are able to calculate AC, it's now easier for us to calculate AB, because AB is going to be AC minus AB, just like that. So let's calculate DC, guys. So calculate DC. All right, so according to this triangle, this angle here, this is your opposite and this is your adjacent. So remember the ratio which is opposite and adjacent is tan. So it's tan theta, which is tan 35 degrees, is equal to opposite, which is 150, over the adjacent, which is DC, the one that you want to calculate. So you're going to cross multiply here. So it's DC times tan 35 degrees, which is equal to 1 times 150, which is 150. Okay, so to find DC, definitely we have to divide by what? By tan 35 by tan 35 both sides. So this will give us DC, okay, which is something like 214,222, something like that. Like that's gonna repeat, which is DC is 214,222, and these are meters, so this is going to be meters. So we have this DC here. So like I said, if we have got D to C, which is 214,222, it's going to be easier for us to calculate this AC. How? We are going to use this whole triangle now. So remember, it's a right angle triangle here because these are vertical and horizontal lines. So that's why we are applying these trig ratios, because this is a right angle triangle. So this time I'm going to use from A to D to C so that we can calculate this whole AC. So don't focus with this B to C, this one. I'm not focusing with this. I'm focusing with the whole of the triangle. So I'm going to take this whole angle, this one, which is this whole angle of 40 degrees this time. So it's going to be 40 degrees. Our DC is there because DC is part of the whole triangle like this. So it's now easier for us to calculate this AC. Why? We can apply the same thing because this is opposite, adjacent. So we want to calculate AC. All right, so it's going to be tan theta, which is tan 40 degrees, is equal to opposite AC over the adjacent, which is the adjacent, which is 214,22. So we can actually cross multiply here. 1 times AC, which is AC is 214,222 tan 40 degrees, just like that. Okay, so you can actually multiply the 2 come out, and see, we're going to have 179 actually, 7536, something like that, which is 179,754 meters to 3 decimal place. That's our AC. So it means this whole of AC is there, 179,754 meters from this point to this point, and we are given B to C from this point to this point, and we want to find this here. So how are we going to find this piece of AB? So as you can see, AB is the difference between this AC minus BC. That's our AB. So therefore our AB is going to be AC minus BC. We are going to remove this BC from AC, which is 179,754 minus BC, which is this BC of 150. So if we are to subtract this, we are going to obtain 29, this is going to be 29,754 meters as our AB. So that was it, guys, to take this total of 100 marks and so forth. So as you can see, it was something which was you needed to be a very prepared and something like that. So still there's time. If you are not able to make it, guys, we still have time together on this platform to revise more as we prepare ourselves again for the other moment that we have, as we know that we still have another trimester to come, so we can utilize that one again. If you see that what you had there is not exactly what you saw, or if you count your marks and see that they are not matching, or they are not giving you the exact thing that you actually needed or what you expected. So but that's it, guys. Fear not, because still there is a chance, there is an opportunity to come, and also a preparation again, especially to those who just met us along the way, especially the last minute of revision. Maybe that could be some of the effects which can actually affect the final result. But anyways, we still have the time to change whatever mark that we need. That is for the other trimester to come. So that's it, guys, from Mason African Motives, working on revisions on engineering, that is in this case mathematics, engineering, science, and all, and other subjects. So not to miss these classes, make sure that you become part of the family Mason African Motives, and also to share our platform to your friends and colleagues. Share this platform so that someone else there can also benefit from this platform that we are having as a family. From Mason African Motives, till we meet again.